going to get it wrong. Bar length, hopefully you'll prove me wrong. Bar length. And then after that we have the mass per metre and the weight overall. So mass per metre, the weight. And over on the far side here we're going to do a sketch. So let's have a look at what we've got, and I'll just summarise it. So it's kind of a T-shaped retaining wall. The ground is over here. So when the ground is over here, this is the bit that's open to the air. So when we talk about each face and far face, we're looking from this side. We're looking from the side that's not being retained. So therefore that would be near face and that would be far face. But because we've got them on both, we call it each face. Now there's abbreviations for those and they're not too hard to remember. Near face is NF, far face is FF, and each face is EF. Yes, that's not with half a mark by the way, but it was very, very quick of you. So you're going to have to put that abbreviation into there, and I'll do that in a second. The next thing to look at is that when I do a sketch, it is only a sketch. All right, do not copy it. Think about it. With reinforcing, it's exactly the same with bolts, and it's exactly the same when your grandmother used to do the quilting of the thing that's on top of your bed. Where did she stitch it? Did she stitch it in the middle or right around the very edge? Come on, own up. Who's done quilting before? No? There's no real men in here, is there? No. No all black potentials? No? Okay. So quilting is a thing where you make kind of like a duvet, and to make it the proper strength, you do the stitches around the outside. With reinforcing, we push the bars right hard against the cover. Now this morning we talked about the cover and the reason for it. For example, yeah. Beg your pardon?
To avoid them from the rust.
Yeah. So we've got to push the reinforcing to the edge, not over the cover. So it's against the cover. If my hand was the cover, it would be right there. Okay. And that's how we work out how. So for example, this piece here, the sketch shows me it's inside here. So this is all 400 all the way up, but there's no reason why that bar can't go in behind the other bar, which means if we push it against the cover is up the top there, 50 mils. So that will be 400 minus 50 minus 50, and that's what it would sit hard against. So we already know the width of that bar is 300. The only time when you can't push it against the cover is if there's another bar in that direction stopping it from going any closer to the cover. So there are times you have to think about it. Same with these. Even although I show that in a sketch as being overlapping, in actual fact both bars are in behind each other. They're exactly the same. One's upside down and the cover is 50 mil, so that would be 2000 minus 50 minus 50, and that would give me the overall length of that bar. So it is fairly basic, the maths, it's not too bad. But you're starting to get the hang of what I'm talking about in terms of pushing it to the outer extreme. This one is an old exam question when you had to sit an exam in this subject back in 2010. So it's got a few other things here, like they call that binding concrete, which is kind of like a builder's mix that gets thrown down there before you start the job. It's got some drainage, which you have all got, or filter material. and a drain, and granular backfill, not blackfill. So it's got a few things here, but at the end of the day, we're only interested in doing the reinforcing inside. The other mistake students make is I say, how many bars are there? And they go, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there's 25 bars. Okay, that's the answer. Roger's already given it to us. See the wee donuts? No. You've got to work it out, and you'll actually find that that's not. Because this is a sketch, I've only sketched it. We need to work it out as engineers properly. This is very typical of what I used to get. That I'm not a registered engineer. A registered engineer would come into the office, sort that out, right? That's his design or her design, and you would have to turn it into working drawings and do the bar schedule. So it's not unheard of, that sort of thing. Yep.
How do you figure out the faces?
This here is all granular backfill, which is kind of like a very fine material made of rock. So this wall is holding that back. Right, so you've got a property and you've put a retaining wall in and you're stopping anything coming any further. Yeah. So you're looking at the face that's got the ear. You don't have a retaining wall with dirt on both sides. Always one side's being retained. So if this was a retaining wall and I'm looking at it, then this would be near face and in the other room would be far face. Okay. Right? Okay. You don't have to worry about that on our assignment because we're looking down on a slab. But you will in the test. So do remember it from the test. Okay, so the first bar we're going to look at is 1201. 1201 is the donuts. They're all over the place. All the way down here, all the way down here. So when you get a complicated drawing slab like this, we divide it up. And there is a reason for dividing it up because we've also got something different called a construction joint. Now, there is, you would have heard perhaps before of an expansion joint. And the chap at the back in the lecture this morning mentioned about concrete expanding and contracting. We often have expansion joints just for that reason. I'll give you an example, a bridge. You know, when you come up to a bridge on the road and your car goes thump, and you go off the other end thump, and you carry on. That's an expansion joint, and they fill that up with a bituminous type mix that takes up the expansion. All right, so you'll get that thump thump as you go off a bridge, and that's why often in major earthquakes all around the world that go up and down, often you'll see a bridge is dropped and the road level's up here and the bridge is down here because the concrete was always separated from the other concrete leading on to, or the whatever leading on to the bridge. That's not an expansion joint, that's a construction joint. That means that they will pour this concrete here and they'll leave this reinforcing sticking up, and then when it's settled, the concrete's set, they'll come back, they'll put the shutters up there and they'll pour the next bit of concrete, and before they do that, they'll join the reinforcing with the lap and they'll tie that together and away they go for the next lot. You might have noticed on building sites sometimes you see these sticking up. Well, they used to just leave it like that, but now they put little cups on the top. And the reason for that is exactly the guy that I was talking about this morning that's built about this wide. He used to tell us stories of men falling off buildings and landing on those and ending up with like a skewer when you're eating chicken. and the cups apparently stop that from happening. I don't know if they do, but you can easily fall on them anyway, just trip on them. So it's the last thing you want. So they protect those with little cups. So you've learnt something today about health and safety. How about that? So we're going to calculate all of those bar lengths, all of their dimensions, and all of their weights. So let's start with 1201. So we're going to have this bit, and the bottom bit. So in a nutshell, we're pretty much going to do this 1201 here. We're pretty much going to calculate this bit, we'll call that A. This bit, we'll call that B. And this bit down the bottom, we'll call that C. So let's start looking at A. So to work out how many bars there are in A of those donuts, we have a distance of 2,500 from here to here. And we can't lie the bar on the construction joint because it's running that way and the whole bar won't get concrete around it. So we have to lift it up, the cover. We have to lift the cover up down at the top. So we end up getting 2,500 minus 50 minus 50. So let's do that. 2,500 minus 50 minus 50 equals 2,400. And we're going to divide that by the bar centres. What does it say at the top about bar centres? All bar centres are 300. So we're going to divide that by 300. And what do we get for an answer there? Sorry, that's not worth 8 marks. I mean half a mark. 8. Someone a bit cleverer than me at maths. How about that? Okay, so that's 8 bars, right? You happy with that, Mr. Mathematician? 8 bars? Right?
Yeah.
Wrong.
Just 2,400% there?
It's 8 gaps.
No.
I said everyone would get it wrong. Which means how many bars? 9 bars, right? Wrong. There's bars on the other side too.
18.
Times 2 equals 18, right? How about that? You all happy now? You should be, because that's right, okay? So let's put 18 bars there. 18 bars. So take A away, and we'll call that 18. Let's go to B. So when we do B, it's a bit different. When you go vertically, it's easy. You take away cover, take away cover. When you do B, it's complicated. And this is where it's going to get complicated in your assignment. I'll do a big blow up of this. So the bars go like this. And they go like this. Alright? And the donut starts there. But what's that distance? Well, the distance is going to be equal to 2 times the diameter, 1 times the diameter, and the cover, CVR. And it'll be exactly the same at the other end to find the centre line of those bars. So we do it centre to centre, horizontally. So let's put that into maths. What's 2 times the diameter? Hold on, is it diameter of that bar or that bar? It's actually the one that wraps around it, right? So that's 16 mil, so that'll be 36. 1
32.
is 16 and the cover is 50. So that distance is going to be equal to,
That will be 32.
oh, well done. No, not half mark. I get that at 90 something. What's that? 90, 98 or 88? 88. 50 plus, big pardon? 98, yeah. And the other end is also 98. And the overall length from here to here is 2 meters. See up there? So it's going to be, the equation for that is going to be 2 meters minus 98 minus 98, and then it needs to be divided by 300. So have we got someone that can do the maths on that? Here we are. We'll do that on oh, you need your calculator this time, yeah? But you did the first one so quickly.
Yeah, 6.01.
6.01.
That's total overall.
Oh, well,
Yeah.
what did that equals 6.01? What did this come to here? 1802 or something, did it?
29.
Oh,
Just testing. Okay, 1601. Is that how many bars there are? Or is it how many gaps there are? Gaps. Very good. And that means it's 9 bars times 2 equals 14. Right? Or is it right? I did say you were going to get it wrong. Now remember, in New Zealand we over-design. Like I said this morning in the lecture, because of Christchurch and every other thing that's happened with earthquakes. Does that go up to 7? Or does it stay at 6?
7.
You think 7?
Go up to 7.
Lots of 7s here. Fishing for a half mark. Okay, I'll let you out in misery. The rule is 0.2 rule. Please don't forget that, because in the test I've got 0.199s and I've got 0.2s. And every student puts their hand up and goes, was it up or down for 0.2? The answer is 0.2, it goes up. So if that was 6.2, you guys would have all been right. If it was 6.1999, it would stay at 6. Right? Don't forget that. So in actual fact, that is correct. I'm just playing with you a bit. All right? So that's 14. So this becomes 14. And you have a look at the bottom, because that is 300, and if you take away the cover, that makes 250, and it's 300 centres. You can only put 2 bars in there. So that's all it is, 2 bars. 2. So the number of bars is 18 plus 14 plus 2, which equals and 2 34. Yeah. 34 bars. It's an alcoholic's dream, isn't it? 34. Well, at this rate, we're still going to be here about midnight tonight. We've managed to fill in one number on the bar schedule. Yep. Okay, there is a bar mark there that we can copy, so 1201. And I've already talked about the location being each face, but we've also got the top and the bottom, so that's easily covered. EF E, F, and top and bottom. Alright? So you can have a combination of them all. You can also have each way, EW. But we haven't really got very far. We've managed to figure out one box. Anyone like to have a stab at how long that bar is? Going from here into the wall. I'll open it up to half a mark for a few seconds. You're allowed to answer it as well, but you won't get the mark.
5 meter.
Very close. Unfortunately, it's 5 minus the cover at each end. At
4.9.
4.9. Yeah. So I better actually write that up here so that anyone, you know, when you're copying the answer, yeah, length equals 5 meters minus 50 minus 50, which equals 4,900. Now, here's another one for you. Another half. Gee, I'm throwing away all these marks. Bar length is 4.900. Why is it 4.900 and not 4.4900? Everything seems to be in millimeters. We're drawing in millimeters when it comes to your drawings. We're talking in millimeters. I've just been doing millimeter calculations. I get over here and I suddenly put 4.900. Half a mark. This is a mechanics mark. Boy, way, and I would be very disappointed in you guys. Mass per meter, you can't work out the total weight in kilograms without putting things into meters. Doesn't work with millimeters, alright? A lot of my students don't do that, and they end up with 4,900. They multiply it by the mass, they get a weight of like 6 million, and they don't take the noughts off, and that's the kilograms that they come up with. So if you want to do it into kilograms, which is, if you type right now into Google how much is steel, it'll tell you in kilograms the weight of steel. So we're talking about putting things into meters. So there is a mass per meter there that's on the chart up the top, and you'll see at this end for a 12 millimeter bar the mass is 0.884. And now the gentleman there that's doing the maths so wonderfully for me, 34 times 4.9 times 0.884. And just off the top of my head, I think it's 147.27, something like that. Is that right? Yeah. Thank you. It's all right, I've got the answer over there. I'm not that clever. You won't find me on the chase. All right. Lastly, of course, we need to draw a picture. The cool thing about a straight bar is you just put the word straight. Have to be careful talking about straight bar though. Here we go. Let's put that across there.
0.884 का से
How do you get cancelled?
कहाँ पे 0.884 mass
Okay. The next bar, and by the way, there's a slight mistake in my example answer. I put each face. It's not wrong, but you should be also adding the top and bottom to that. The next one is 1602. Which one is 1602? Let's have a look. Oh, that's not too bad. It's straight. It goes from the top to the bottom, but I do notice that the sketch has got it right on the construction joint. Is that wrong? Well, technically it's not wrong, because you can have the point of the reinforcing bar there, just you can't lie it on it. Alright, there's enough concrete getting around the point there. Okay. So what we need to calculate is 2,500. So let's do that. So all of this was 1201. Let's do 1202. So it's 2,500 minus 50 equals 4,900. So that's the length of the bar. That's easy enough. Now, how many of those bars are there? So you should be able to get this one because it's
Then
going
it should be 2490.
2 foot. No, it's the length of, he was close before when he said 5 meters. So these bars are going to go for the whole 5 meters minus the cover. So it'll be 5 meters minus 50, which equals 4,900 divided by 300,
300.
right? And we all know that equals 16.333, is that right? This time I'm not using the model answer.
Yeah.
Which equals how many gaps?
17.
Yes, 17 gaps. If you can tell me why, you can have half a mark.
Because it's more than 0.2.
Correct.
Yeah.
He just applied the 0.2 rule. It's more than 0.2. And of course that goes to 18 bars. And guess what? We can put 18 bars and 4.9 over here on our thing. So we're going a bit quicker now. So barley is 4 points. What's going on here? 1602 is the bar, isn't it? Is that right? Yeah, 1602. And the bar length is it's not, it's the length is actually
Less.
is 2,500
Yeah.
here.
That's 2,453.
Sorry, I got that wrong. It's 2,500 minus 50 equals 2,4. Just minus 50 equals 2,450. Yeah.
Yeah.
Sorry, my bad maths. What happened to my checker? Must have been asleep then. 2.450. And how many did we get down there? 18, didn't we? It was actually 36 because there's 18 there and 18 there. Times 2 equals 36. So there's quite a bit of thinking to do when you're doing these. It's easy to make a mistake, isn't it? I just made one then because I just assumed it was one, but there's one each side. 36, 18 altogether on each side. 36. And that is each face, because there's one at the front and one at the back. And if we go up to the top chart there, you can see up the top, it's 1.578 is the weight of the 16mm bar. And if we multiply that by that by that, and try and beat the teacher, we get 139.18. And straight. Now it's time to draw pictures. The next bar is shaped like that. If we push it to to the very edge, it's going to be 2 metres minus cover each side. So 1.9000. And the width of that bottom anchoring slab is 400, so that'll be 300 when you take off the, so that'll be 0.300 and 0.300. Sometimes people do these in millimetres on the sketch. You don't have to draw the sketch to scale, just a stick line will do. Okay. This next one is going to be bar number 1603. And this time it's going to be top and bottom, because we're on the bottom part of the retaining wall. And the good thing is we don't have to do that calculation again, because that bar there and this one tie on to that one. It's going to be 18 all the way. So there'll be 18 of those and another 18 of those and another 18 of those. But this one here, there's 2 of them, that's only 1 of those. So the 2 times 18, you get 36 again. We don't know the length yet. We do know it's 1.578. So we've got to calculate the length. And this is what I was talking about in the lecture. To calculate the length, we need to draw this little figure out. This is 1203. So it's 300, 300, 1900. So I was talking about the steely guy that bends the steel. The whole idea, you can't bend steel at right angles. So there's going to be a curve. And when you curve something, you kind of cut the corner, so it makes it smaller in length overall. And the corner cut is given to you up the top there by the 90-degree bend allowance. See that? And for a 16mm bar, it's 36. So in other words, because that's going around the corner and round the corner, it's minus 36 and minus 36. So what it ends up being, overall, the overall length of that is 300 plus 1900 plus 300 minus 36 minus 36, which equals, I'm not going to have time to get back, he's going to beat me this time.
2428. 2428.
2.2428. Is that right? Is that what you said? 2428? Does everybody else get that that's been staying awake? Yep, 2428. So I'll put my 2428 here. And now we're going to multiply that by that by that. And we're going to get an answer of 137.93. Lastly is the U-bar. Now the U-bar is going to be 300, we already talked about this bar. It's going to be pushed against the edge, so it'll be 300 because it's 400 minus 50 minus 50. Better put that over here. 1204. It's going to be 400 minus 50 minus 50, so it's going to be 300. It's the height that's the problem. So to work the height out, it's going to be, I do it this way. The height of this is 300, the next is 400, the next is 100, and the lap is given to you up the top of, now which one do we take? Where's the lady from this morning? She can tell me. Which lap do we take? The 390 or the 520? Perfect. That's half a mark for doing that. There we are. I'm being generous. Once again, you better start emailing me before midnight. Yes?
Yeah.
Why we did not minus bend in the first one?
Because we're trying to work out when you give the bar to the steely, he measures the overall length and then he bends it. And when he bends it, if your overall length is just 300 plus 19 plus 300 and you bend that, you're going to end up with too long. Right? But if you take off that and take off that and you give him that length, when he bends it, it'll be perfect. Alright? So it's called a bend allowance. You could draw it on AutoCAD and you'll find that it's pretty close to what the actual length. You do a P-line, do a curve, list the P-line and it'll tell you that the length has changed. Yeah. So let's do that. That's 300 plus 400 plus 100 plus a lap. So it'll be 300 plus 400 plus 100 plus a lap, but we have to also minus at the bottom this cover. So the lap is the lady there said, 520, correct, 520 plus 100 plus 400 minus 50. There we are. 300 plus 400 plus 100 plus 520 minus 50.
Mm, 1270.
How much?
1270.
1270. Thank you. So that's the height. 1270. And 0.300. 1604. This one will be top and bottom and each face. There are 18 of them because we've done that calculation before. And the bar length is going to be equal to, now this is going to be equal to 1270 plus 1270 and plus, so the bar length for this one is going to be equal to, length is 1270 plus 1270 plus 300 and then of course minus 36 minus 36 and we get an answer there of an overall length of
2768.
Sorry?
2768.
2768. Yep. Two, 768. Yeah. 2768. 2.768. It's 1.578 is the weight. We multiply that by that by that. The answer is 78.62. Now, One thing missing, total. Now, please, when you do your assignment, don't forget to add them all up, because the whole idea of this is to get a total so we can get a price on. Just doing that is not enough on a schedule, right? So when I allocate marks, even although you may have not got all this right, your total might be close to mine, and I may decide to give you a half a mark for your total, alright? So it's worthwhile doing that. Or it could be just a thing that bumps you from a adequate to a good, which is 75% compared with 50. The total here is 503.00. And probably put a kilogram there anyway, just to remind the client. Alright, it's the longest I've been on my feet for a few days, doing all your marking. There's the calcs down the end. The good news about what I'm about to show you and make available on the internet is I have got something that might also help you, is the not that one. But this one here I'll make available, the answer. Okay, so we started off by dividing that into 3 areas. We then worked out A, the first one, by taking the distance from here to here, and we got a calculation to give us 14 bars. And we applied the rule, but the rule didn't really apply. It was just still became 6. And I told you about the 2 diameter, 1 diameter, and the 50 for the cover, and the bend allowance. And we applied that to 1603 and 1604, and there's the last one that we did, and we ended up getting those answers there, which should reflect what's on the board.